In part 3 of this tutorial series, we will create a simple golf course so that we can start testing and tweaking the physics of our ball. So before we get into the physics properties of the golf ball, we'll need to create a little sample golf course for us to test on. Going into our mini golf models, we're going to grab the straight piece. Oh, make sure our scene here is open. Our straight piece here. And then we're just going to add a mesh collider. And then we're going to turn this into a prefab. So create folder, prefabs. And then let's take our straight piece and drag it in there, original prefab. So now any changes we make to this piece will then also be made to this piece here. And when we drag this piece out, it will also have the mesh collider already attached. Now because this is a modular system, we'll need to snap these pieces together using Vertex Snapping. So holding down V, when you put your mouse near a vertex, the snapping tool will appear. So we'll just grab the corner here, left click down, and bring it to the other corner. See the other corner of the other piece? And now we have two pieces seamlessly connected. So rather than grabbing each one at a time, we can just select both of them, Shift select, Control D to duplicate. And then with both of them still selected, hold V, Vertex Snap. And then what we can also do is we can go back into our models folder, find an end piece, add that mesh collider, prefabs, bring our end piece into our prefabs folder, original prefab, and then vertex snap it onto this end. And let's bring another one. Now we want to turn it around, so we can press E to get the rotation tool, and while holding down Control we can select this little part of the gizmo. That's the Y rotation. Back to W, then V, and then bring it over there. So holding down Control while rotating will rotate it in steps and segments of, I don't know how many, yeah, in segments of 15 degrees. Okay, so let's get our ball, W, and let's bring it to one end of our little course we've put together here. We can just get rid of this cube now. We don't need that anymore. And let's set up our camera. We see the camera preview here. Let's set that up in the angle. So for our game, we're going to have a orthographic camera, which gives you no depth. And then we want to set our Y to 45, so we're seeing it on an angle. And then we'll set our X to 35. Now with the X, you can, there's more leniency there, whether you want to see more of a top down, more of like a side on, but I think 35 is a pretty good sort of spot to be in. You still get that depth, but you're still able to kind of see more of the space from above. And then we want to set our near clipping plane to 0. and then go back to our scene, and we'll need to move our camera a bit further away. Oh wait, sorry, that's, yeah, because our camera is way too close. So let's move that a bit further away. Now to make it zoomed in, we actually have to decrease the size. So decrease it to about here, back to scene. And by selecting this little blue square here, if I can get close enough, here we go. We actually just drag the camera view around where we want it. About here is good. All right, let's save that. So getting the physics for our ball right. If I just hit play now, and then let's do a full power shot. So first of all, as you can see, the ball just keeps on sliding. So let's take care of that. There are two components to the physics of the ball. There's the rigid body, the drag of the rigid body, and also the actual physics or physic material, which will have your friction. So starting off with our rigid body, now something that I've done is, and this is something when you're working with physics, when you're, unless you're doing a simulation, often it involves playing around with the actual project physics settings, the rigid body settings, the physic material settings, all of those things, and just playing around with those until you get a balance of what kind of feels good for what you want. So I've gone and done all that, and these are the numbers that I found work well for what I want to achieve. So a mass of 0.1, because the ball is quite small, and then a drag of 1 and an angular drag of 1, and that's just going to help slow the ball down by giving it more drag as it's moving through the air, and then angular drag will slow it down from spinning. Then we need to create a physic material. So we can just go create physic material, and let's just call this ball physic material. And then when we select our ball, we can drag that physic material onto the sphere collider, and then click on our ball physic and set our dynamic friction to 0.1, static friction to 0.1, bounciness to 0.6, because we want the ball to be able to bounce off the edges and off obstacles. Because being able to deflect the ball off walls and surfaces and to get angles on certain spaces is a big part of putt golf or mini golf. And so for friction, we just want to take the minimum, because all these track pieces and any obstacles will have a default physic material which will have a much higher friction, dynamic friction. So we just want to use the minimum, which is the one that we set. And in terms of bounciness, we want maximum. So most things will have a default of 0 bounciness, so we want to use our maximum of 0.6 rather than having to calculate averages. Okay, so now with that set, we will also set our max power to 0.7, and I believe that this should give us a result that we want. There we go. So it's bouncing off the walls. It does roll a little bit, but it gradually slows down. And you can play around with this. You can increase the friction, make it, slow down faster. There's a lot that you can do with this. So just a couple things to kind of a couple little tricks, there's 3 little tricks to know about physics that are kind of, a lot of it specific to golf balls. The first one is the collision detection. So something that can happen is that if your ball is moving too fast and it's near a thin collider, it can sometimes actually just end up going right through the collider. So what they for objects that can possibly move quickly and there are possibly thin colliders, you want to set your collision detection to continuous dynamic. And another little thing is that while this appears to be seamless to the physics engine, these gaps, these joins between each of these pieces, while it looks seamless to us, to a physics engine, there is some degree of difference, and it's something to do with possibly like the uncertainty of the position of these objects, because they are stored in floats. So that could possibly lead to a difference in the value of these positions, because they're not going to be exact. And so because these have hard edges, when the ball is rolling at a high speed and it encounters a sudden difference in elevation, even if that elevation is very small, it can cause the ball to just suddenly just jump up in the air like it's hit a road bump. Let's see if we can get that effect. No, it's quite smooth, but it's just something that can happen, especially if it's not. Oh, there we go. There we go. So you just saw that happen. It only happens sometimes. Oh, there we go. Big jump there. Yeah. So there are many different approaches that people make to ensure that it never happens ever. But there is one thing that you can do. Whoa, there we go. Went right off the map. There's one thing that you can do to really kind of help prevent that from happening. And that's just by going into Edit, Project Settings, into the Physics tab. And you just want to decrease this contact offset to a much smaller number. So it could be something like 0.001. And that should really, it's not going to make it completely, proof of that happening, but it will significantly reduce how often that does happen. So what that's essentially doing is it is preventing the ball from, as it's going across and entering the new piece in front of it that's slightly higher. For a split second, the ball will be partially, inside the collider of the next piece because it's slightly raised, and then the physics is like, oh no, the ball is not supposed to be inside the collider, so it just pushes and forces it out of the collider, and then that forces it up, and it ends up just flying up in the air. So yeah, I mean, there's a few different more complicated or advanced ways of dealing with it. Some people have tried putting colliders, little trigger zones on every single gap that limit the y velocity or the y that limit the y position. Or possibly you could prevent the y velocity of being greater than a certain amount to stop it from just shooting up in the air all of a sudden. But that would, have impacts on maybe if you are trying to run your ball into a tree and it, runs up the root and up the tree, you know, then that wouldn't be possible. So I found that this really did help. Did help a lot. So if you see here, you can see it's not going to be really jumping too much. And then the last thing is the bounce threshold. So something about golf, and as I said before, the bouncing off the walls is really important. And if you hit a wall hard enough, yeah, you'll bounce off it. That's good. But see there, if I'm not going fast enough, I just kind of end up sliding up against the wall, which is not great. If you want to do some very kind of light little putts up against the wall, you know, like this. Well, that was a bit too soft, but I'll give you a better example, a bit more power. So if you're on a bit of an angle here, that bounced. Let's try here this way. Oh, I can do it this way. But see that? It just slid up against the side of the wall. So what's happening is that there's a threshold that will prevent a rigid body from bouncing if its relative velocity to the object that it hit is lower than a certain amount. But because we're working on a very small scale, that the threshold is too high. So if we're too slow, it's not going to allow for any bouncing. And this is mainly put in place to prevent stuff from just constantly bouncing all the time indefinitely. You'll see if you set this threshold to 0, the ball will just bounce and vibrate on the spot. I can show you. If you go to Project Settings, Physics, set your bounce threshold to 0. And then so you can see how our ball is a little bit above the ground, and watch what happens when it falls. It will just be bouncing and jiggling around like that. You can see the Y value changing. It'll never sit still. So I found that a good threshold is 0.8. And this allows us to have some bounces, even if we're going at softly. That was a bit too soft. Let's try 0.6. Oh, there we go. We got a bounce there. Try 0.1. See, that does cause just vibration like that. Let's try 0.3. Still getting it. I mean, there's a certain limit to, you know, there's only so low you can go before the ball is just gonna be jiggling around and bouncing on its own. So if I just do a little gentle putt, yeah, see, so yeah, I mean, it is gonna help in certain circumstances like that. I mean, if you're gonna do a very gentle putt, you know, it's gonna go up along the wall, you know, which is something you would see in pool or something else. Yeah, so that's kind of normal, but it will help just for those ones where you're going slowly and because you've lowered the threshold, you're going to get more bounce. Yeah, that's fine. But I mean, it's not guaranteed, you know, to give you a bounce every time. You would need to do something else for that. But just in general, it will give you a bounce at a lower velocity than otherwise you would. So that's the best you can really do. And in fact, I would project settings. I would set the bounce threshold a little bit higher just in case, because that's right on the limit. So you know, otherwise you can get some very funny kind of behavior if you get caught in a funny spot and it's all just jiggling and bouncing around. But yeah, I mean that's fair enough. Yeah, you'll just have to, if you want to get a bounce, then you got to hit it hard enough. Like that, you can get 2 bounces like that. And if you want to go along the wall, just do it really softly. So even at a half power, you get a bounce. So I think that's good enough. Just give that a quick save.